All right, class.
Yes.
Okay, not bad, not bad. Could be better, could be better. Working on it. So, verifying trigonomic identities, it's a lot of stuff that we did already, but now it's going to give you an answer that you want to get one side of the equal sign equal to the other side. So, it's a lot of algebra skills, and the algebra skills that you will need, I'm going to go over them. So, what you're going to have to do is make a list of the things that you can do with your algebra skills, like multiplication property, or common denominator, or separate common denominators, stuff like that. That's going to be what you need to do, because every year we keep changing curriculums for this. Every year I have to teach it differently because you students did not have the same algebra that I did 2 years ago. You didn't have those same algebra skills, so you don't have the same, steps and equations and all this other stuff. You didn't have that same stuff for all the algebra identities. I taught algebra 3-4 last year, and we didn't do any algebra identities. And so that's one thing I'm worrying about. So when I say you need to make sure you write down different steps, because these are the tools that you're going to use to try to replace or try to make these work. All right. There's only one thing you're getting out of this. You're going to rewrite the more complicated side. Okay? That's the part you're going to have to get out of this. And it's going to make sense when we actually get to one of the problems. Is this one it? No. Here it is. So, my first problem here says cotangent theta plus 1. Cotangent theta plus 1. If we were paying attention the other day on 5.1, what's the first thing I should do with that? Nope.
Convert it to
Algebra, right? Translate it into algebra. Translate in algebra. So the ones that we did for those are specific for the 5.1. Okay. So these ones converting it to algebra. So now, if you need your reference sheet out, please have that out, because that's going to give you your X, Y, and R. That's what you need. You need the X, Y's, and R's for this.
Can you just use the unicycle?
No.
Because it has the thing inside.
It does, kind of. Okay. What's up? You need another one? Okay, yeah. Yes. A what? Yeah, come on down. Anyone else? Very good, thank you. Are you taking selfies right now? Really? To prove that you're in class? Is that what your PO says you have to do now? You have to take a selfie all the time to make sure that you're still in your classes? Hey, I'm glad that they finally took off that ankle bracelet, though. Those are annoying.
It was hard to wash.
Yes, I
I
know.
almost electrocuted myself.
All right, so we're translating this one here. So cotangent is
X over Y.
very good. X over y. So it's x over y plus 1 is equal to, now, cosecant. What does cosecant translate into? 1 over y, because these are identities, right? And in an identity, my r value is always, thank you. So it's 1 over y, parentheses. Now cosine, what is cosine going to be? X over 1. Okay, I'm going to put it as over 1 right now, because I'm going to be multiplying by a fraction. Sometimes I do, sometimes I don't. So this one's going to be x over 1 plus sine. What is sine going to be? Y over 1. Very good. Y over 1. Now, the thing that I underlined recently on a couple slides back, it said you want to try to clean up the more complicated side. Which side of the equal sign here is the more complicated? The left side or the right side? The right side's more complicated. So there's something to do there, right? On the left side, there's no operation to do. It looks like that. It doesn't say multiply, it doesn't say divide, it doesn't say, combine like terms, it doesn't say, this one over here, I could do distribution, right? That's what's going to make this one more complicated, but it's also going to make it easier because it gives you something to actually do first. On all these identity problems, that's what you have to do. You have to look at it and say, all right, I need to make the left side look like the right side. Or I need to make the right side look like the left side. So I just pick which one's the more complicated and I use that. Right here, there's going to be distribution, right? So when I distribute, I multiply fractions straight across. I multiply top times top, bottom times bottom, right? Say yes. Okay. So if I'm multiplying top times top, 1 times x is? X, very good. And then on the bottom, it is y times 1 is? Because I asked. I tried so hard. And in the end, it doesn't even matter. So now I'm going to distribute to the second term. So you can see, I'm actually going to take an extra step out of this. So you could jump straight to the capitalization if you want to, but I'm going to show you what's going to happen. So now, top times top. So 1 times y is? Over y times 1? Very good. Now, what happens if I have y divided by y? Yeah, it's going to cancel out, right? And if it cancels out, it becomes 1. So now I could replace the y over y with 1. So I have x over y plus 1. Now, does this match here? Yes, it does. That's what we're doing by verifying the identity. So we're making the left side equal to the right side. Yes?
So essentially, like when they say verify, it's just making sure that it's the same?
Yes. Now, I'll give you a secret here. I'm going to whisper it really loud. It's always equal. In none of the problems I give you, it's not going to be equal.
So you're never going to verify and it will be not?
Incorrect. You're going to verify, and it's always going to be true.
Right.
You just need to find how it got there.
So
Now,
would be false.
none of them would be false. And what I'm looking for here is the process that you're using. Not everyone's going to have the same process to get from here to here. This one's an easy one because it only has a distribution on this side. Does that make sense? Okay. Sometimes you're going to have different things. Now, when I'm looking at homework, I would like to see all the work. I want to see the translation. I want to see the steps. And I want to see the final that this matches this. Yes?
You know how you said that the steps can be different?
Yes.
Where it says x over y plus y over y, couldn't you cancel the y's?
Yes, you could have just canceled it and made it 1. So when you distributed to that, that's why I said I was going to do an extra step there. And I put the y over y so I could show y divided by y is 1. And that's all I was getting at. Yes?
Well, I was just gonna ask why we have to verify the identity.
Because that's the whole portion of what we're doing. So you're using your algebra skills to manipulate these identities. So when you move on to calculus at some point, you will have to make an identity or manipulate an identity to actually fit for your work. Okay? All right, so let's go on. And I normally do one problem, then stop or pause and let you do some of the problems. But I got to do example 2 also. Because on the homework, we have to do 1 and 2. I think it's example 1 and 2 for the first homeworks. Now I got to verify that because where I looked at it already, and it is 1 and 2. What's the first homework promise? Mine starts on 35. And those are going to come in later. Okay. All right, I'll do 2, and then we'll stop there. Then from there, we'll actually work on homework. Okay? So from right here, we need to go through and do the translation to see what it's going to look like first. So what is tan squared going to translate to? Y over x. And if it's squared, it is? Very good. So it's going to be y squared over x squared, parentheses, 1 plus, and cotangent is?
X over y squared.
Very good. So it's going to be x squared over y squared. Close it, equals. Now on the bottom I have
1 minus y over 1 squared.
yeah, y over 1 squared, but I'm just going to, because it's already a fraction, I'm just going to say it y squared. So I don't want to make it look confusing because it would be y squared over 1 and yeah. Yes? Now, this one right here, we're going to verify it, but we could use both sides. We could do both sides or either side. And it will make sense here in a moment when we actually do this. You don't only work on one side, you could actually work on both sides. So let's take care of the more complicated one first. Which one's more complicated first? The left side, right? The left side is more complicated. So let's do my distribution here. So my distribution here is going to give me, very good, y squared over x squared. And as I distribute, it becomes plus yes, x squared y squared over, remember the bottom also, yeah, x squared over y squared, right? Yes? Are you okay? Yeah, multiply top by top, right? Top by top, bottom by bottom. I just put them in order to make it look easier. Does that make sense? Angelina?
Wait, do that one more time. I wasn't paying attention.
Okay, so here we go. All right, help me out. So we're doing the top. So remember, fraction, top by top, right? So now it's y squared times x squared is? Yeah, xy. I'm going to put them in alphabetical order to make it easier, okay? So it's x squared y squared. That's the top, right? I'm just putting them together because it's still saying it's multiplication. And on the bottom, when I multiply the bottom of the fractions, it's going to give me? Yeah, x squared, y squared, right? All right. So now that we see that, what's going to happen to those right there?
It goes in 1, right?
No! Yes, it will. Huh? Really? Have you met me before? That's kind of my deal. Okay. So we are canceling those out. So I'm going to cancel those out. And if I cancel it out, it becomes? Very good. So it's going to be y squared over x squared plus 1.
Wait, is that it?
Almost.
It has to match that, right?
Yes. Yeah, go ahead.
To get rid of the x squared, wouldn't you have to multiply it?
Kind of, yes.
No, okay. That was different.
You're,
Well, there's a step further back.
I was going to say minus 1, but okay.
but remember the equal sign's here, and I'm just working the left side. I'm just working the left side here. But I kind of heard it.
Can you do plus 1 on the other side?
No, I can't do that because it's everything on the left needs to stay on the left. Everything on the right needs to stay on the right.
Oh, can you
All right. So, is there an addition right here? To be able to add something together, what do you have to have? What do you have to have?
The same denominator.
Very good. Common denominator. Very good. That's what I'm looking for. We got to have common denominators. So, what's the common denominator right here going to be? X squared. Very good. So, I'm going to multiply this side right here by x squared over x squared. X squared divided by x squared is still 1. It's the same thing, top and bottom. It divides and gives you 1. So, it's still the same value. It just looks different.
So it's
But in
times
order
1.
to get the other side cut, for it to cancel out, you would do the same thing as
Kinda. I already have an x squared though. Are you talking about over here on the right side?
yeah.
I don't want to do that yet. You'll see. You'll see why. Now, when I multiply that, I'm going to put it over a common denominator now. The common denominator is going to be x squared. So it's going to be y squared plus x squared over x squared. Now, this next piece right here is something you have to be able to identify. Yeah, I'm trying to give you a hint. It's an identity. What? Got to be more specific. Most likely, or it's also in your notes too. And if I was to look at my 5.1 notes, I would say it's slide 3, but I don't have that up here. So Pythagorean identity, maybe.
Is it your sine squared theta plus cosine squared?
Yeah,
Wait,
but
no, wait. It's
It's the
the tan squared.
tangent square. What would be the y squared plus 1 squared equals the 1 over
yeah, yes, you are exact. That would be right here. But watch this. What is y squared plus x squared?
X,
Y
Y.
squared.
Y squared plus x squared. What is x squared plus y squared? What's x squared plus y squared equal to?
Oh,
Or?
R.
R, which is?
Oh.
Which is 1.
Yes, very good. The identity that we're missing here is x squared plus y squared equals.
Oh.
So whenever I can combine x squared and y squared together, I can replace that, both those, with just 1.
So it is basically just the Pythagorean theorem.
Yeah, it is. It's the Pythagorean identity to go along with this. So it's Pythagorean theorem, but the Pythagorean identity says that. So there's one of them. So that means I'm going to replace this right here with 1 over
X squared.
x squared. I'm going to stop this side right here. I'm going to stop that side right there. Now, if you were paying attention on, what did I see, Friday, Wednesday and Friday? The right side. The right side. What can I do with the right side now? Nope. Is it an identity? Yes, it is. We wrote it several times. So, I want an identity to be 1 minus y squared. So I'm going to my next page, and I'm going to use the same thing. X squared plus y squared equals 1. So what would I do to this to make it into 1 minus y squared?
X squared.
Subtract what? Very good. I'm going to subtract y squared to both sides. Your answer is correct, but, actually, step by step. So subtract y squared to both sides, right? And so my identity, I'm changing the identity. I'm just changing the order. I'm rearranging the order here. So this turns into x squared is equal to 1 minus y squared. So this is another one of those identities that we're going to use over and over again. So whenever you see a 1 minus y squared, you should automatically think that I could replace that with,
X squared?
I'm going to replace it with x squared.
Do you have tissue?
I got the brown stuff over there. So over here on the right hand side, I'm going to replace the 1 minus y squared with x squared. So 1 over x squared. So now this, they match. So what I did is, I worked the left side, got it to a good spot, and then I could use another identity to work the right side. You don't only have to do one side only.
So you can, so you don't have to take one and match it with here. You can break it up further.
Yes,
As long
because
as it
sometimes both sides are going to be complicated.
Oh,
And so you could choose either side to try and do it, but you want to try and simplify it down to the smallest terms that you can. And that's what we did right here.
I didn't understand the last part you explained, where you said if there's a y squared, you just make it an x squared.
Okay, see this right here?
Yeah.
See that? So you should be able to look at this and see. So just remember this conversation we're having right now. 1 minus y squared is equal to x squared. So it's something you could do all the time. So every time you see a 1 minus y squared, you should think, oh, that one right there could be replaced with x squared. Now there's another one to go along with it. There's another one, because I'm going to go to it. So
Because of that.
yes, because of that.
Oh, okay. I get that.
Now, instead of having 1 minus y squared, can I make it into 1 minus x squared?
And then get y.
Yeah.
Oh.
I'm going to do the same thing here. So I'm going to subtract x squared from both sides. So I get y squared is equal to 1 minus x squared. So this one right here is another identity that I see.
So if you see 1 minus x squared.
1 minus x squared, you could replace that with y squared. So back and forth it goes. So you can replace just using these identities. And there's also one on the homework that you have to use it, and instead of replacing it with y squared, you need to take y squared and expand it by replacing with 1 minus x squared. I think it's that specific one on your homework. Yeah.
Don't we still need to translate it into?
No, you just verified.
Oh, okay. So we
You're
don't-
verifying. So step-by-step verification means I'm telling you what the answer is. Your job is to get from, here to prove that that was correct.
Okay.
So to prove that at the very end, yes.
So you said every time you see y squared, it can be replaced by x squared?
No. 1 minus x squared. So right here, so you have a y squared, it's going to be equal to 1 minus x squared.
Okay.
And if you have an x squared, you could replace that with 1 minus y squared. Does that make more sense?
Yeah.
Okay, that's just taking my Pythagorean identity here, my x squared plus y squared equals 1, and trying to simplify it as much as we can. So using these identities, instead of me teaching you all the different identities, we just keep making it from this. There's a whole bunch of different identities that you just make from here.
Got it.
Yep. All right. Are we okay? Any other questions? All right. Don't forget, like, share, and subscribe. Hit that notification. Buy stuff at my merch store. And yeah.